Welcome to the MAE 364 lab. This is the kinematics lab that students work on. It's required for mechanical engineers and a technical elective for aerospace engineers. The space is dedicated to this laboratory is 644 square feet with a maximum of 16 students and one graduate teaching assistant. At the entrance to this lab is general information about the campus and laboratory safety procedures. There's only one exit in this classroom. Office of Environmental Health and Safety certifies the safety equipment on a regular basis. Students are required to use personal protective equipment. We have safety glasses here and an eye wash station above the sink. Around the corner, we have a fire extinguisher if we should happen to have a fire in the laboratory. The current laboratory manual is on the table by the door. The laboratory's outcomes to the students are understand how to analyze mechanisms and cams, develop ability to formulate and solve engineering problems in balancing, rotating, and reciprocal masses. Students assemble in groups of 4 and work in 4 separate experiments at one time. There are a total of 7 experiments in this lab. In subsequent weeks, the students rotate through the remaining labs in order to encourage the students to read through the laboratory manuals before the experiment. A quiz about each experiment is over the manual, is assigned to the students before the start of the lab. In the first experiment, students learned how to calculate the mass moment of inertia experimentally from timing the periods of a pendulum. Simple shapes are used so the students can also calculate and compare their results with the theoretical mass moment of inertia. For the second experiment, 4 separate blocks can be placed at various angles and positions on a rotating shaft. Students measure the mass moments of the blocks in terms of the number of ball bearings needed to offset the moments of the blocks. Then they figure out how to balance the system by graphing out vectors on paper. A Whitworth quick return mechanism is used in the third experiment. Students make measurements of the linear position versus angle. They compare their results with theoretical calculations from geometry of the linear positions.
All right.
2 hooks coupling or universal joints are used in experiment 4 to demonstrate how the various orientations of the joints cause different offset angles between the input and the output shafts. In the 5th experiment, it demonstrates changeable speed and torque ratios of an epicyclic gear system. Students calibrate cantilever beam displacements in terms of torques on the gears. Angular velocity is recorded by sensors underneath, which the data is sent to computer. The falling mass is used to measure the efficiency of potential energy transmission to rotating kinetic energy. In the 6th experiment, students measure components from a small engine and use the measurements to simulate the action of the small engine in MATLAB. The 7th experiment is done on computers outside the lab for the analysis of engine kinematics. So we do have a cutaway of a turbocharger that the students can look at and see how it functions. We also have a Scotch yoke or slotted link apparatus to demonstrate how from an angular drive we can get sinusoidal motion. And then we have a scale for measuring various components as students work through the lab. Here we have a cutaway of an automatic transmission. Students can look inside of this and see the various components, which includes the planetary gear train that they also do experiments on. They look at fluid drive over here to see how that is used to decouple for changing gears on the automatic transmission.
Okay.
Here we have a 4-cylinder Fiat engine cutaway that the students can look at the operation of an internal combustion engine. So they can look at various aspects like the camshaft, how it opens and closes valves. They can look at the crankshaft, various balancing points on the crankshaft, and as well as the pistons, how they open and close, and illustrating the 4 different strokes.